Hello friends, and welcome with you with this new video of our new course, Postgresql Indexes, a little more in depth. In this video, we will talk about the internals of the index. How does the index works? Usually, the first step is that you create an index on a column or multiple columns on a table, in a table. And the syntax is very simple. It's either create index name on the table name and then the column name, one column or multiple columns. Then the database automatically will apply this index on any query that you will invoke on that table. Maybe not. Maybe the index will not be applied on that query. That thing we will see down the road in other videos when we see how sometimes the index is not being used when we do some queries. So the index can be used or maybe not used. That depends on certain conditions. But the idea is that you create an index and then this index will be used in the SQL query to improve the performance of retrieving of the data from the database. Now let's talk about the internals of the index. We have a table here which consists of columns and tuples. These tuples cells have values which represent the data that is saved in each cell, in each row. When we create an index using create index IDX on table like this index will be created on this column, and whatever data, whatever values will be copied to all of them will be copied to the index. Now this index will be saved in an index file, special index file, and this index file will be saved in the database in the hard disk. Now remember, if we do a normal create index, all the values of this column will be saved. If we do create unique index, then all the values that are not duplicate will be saved. So give attention to this point. When you create unique index, only the values that is not duplicate will be saved in the index. Now let's talk about the index itself. The index consists of two things, the key and the row ID. The key is the value that have been copied from the row in the indexed column. So each value here, each key represents the data, the same data that is available in each tuple, in each row, in the column that we have placed an index on it. So as you can see, the values here, the keys should match exactly. The data in the index should match exactly whichever data in the rows in the column that we have placed an index on it. Okay, this is the first thing. The second thing called the row ID. Now, one notice, the row ID is an internal mechanism for the index. The row ID here does not represent the ID of the main table, the ID of the rows in the main table. The row ID here in this case is an internal mechanism of the index. This row ID will give us a reference to where the number of the ID of the original data in the main table, which means suppose that we need to retrieve the value C. In this case, we are doing this select query to retrieve the value C. Value C in the main table resides in tuple number 3 with ID number 3. But in the index have given this row, this tuple, row ID number 2. So this number 2 represent or reference, it will be a reference to row ID in the main table number 3, where the key value C resides. So this is the entire idea of the index. Two things, key and row ID. The key is the data or the value which in the table, in the row, in the column that have been placed an index on, and the row ID is a reference to where the tuple resides in the main table. Now let's move on, carry on with things like the indexes planner. Remember in the first video when we said that when we create an SQL query, the index planner will select whichever best index to be applied on your SQL, and I told you that we will talk about later. Now this is the time that we will talk about the index planner and the execution plan. The planner is what you see in here, and the execution plan is the steps that the relational database management system will follow to execute an SQL query. So the execution plan is the steps that the database will follow to execute any SQL query that you put in your database. Now let's take a look about the planner here, the indexes planner or the query planner. Basically it looks like a stack of structure. As you can see here, rows one after one, and it is like this. It is like a stack structure. Now each step in the execution plan, we call it as a node. So each step the query will undergo is called a node. The deepest node is the start point of the execution plan. The deepest node is the start point of the execution of any SQL query. So the plan is a stack structure. It consists of nodes. Each node is a step. The deepest node is the start point of the execution of any SQL query. How you can figure out which one is the start point? Whenever you see this thing, cost equal to 0, it gives us an idea that this is the start point of the execution of the SQL. This is the start point. So the execution started with this node, with this step. Now there are three types of nodes. Three types of nodes in PostgreSQL, and we will talk about now. The scan nodes, the non-table row resource source, and the operations node. The first one is the scan node. The scan node, the objective of the scan node is to go to the table, retrieve the data in one tuple or multiple tuples. That's it. This is the objective of the scan node. So whenever you see a scan node, this means that this node have consulted the table, fetched one row or multiple rows and brought to us. Then this fetched data will be submitted, will be forwarded to another step, to the next step. The next step will come one step on top. So this is the next step. This is the start point. It's a scan node. It went to the table, fetched data from the table, and then it will forward to the next step. The next step will do something on this data, on this fetched data, and so on. The result also will be forwarded to the next step, and the result of the next step operation will be forwarded to the next step, and like so. Now the scan node have three types. In Postgres there is three types. In MySQL there is four types. In PostgreSQL there is sequential scan. You can see SIG scan, index scan, and bitmap heap scan. In MySQL there is constant, there is ref, there is constant, index, ref, which is range, and the final one is sequential. Now in Postgres we have SIG scan, we have index scan, and we have bitmap heap scan. The sequential scan is the worst of all. Whenever you see a 6 scan, that means this is the worst of all. That means this SQL or the index have not been applied on the SQL, and that the scan have gone through the entire table. The entire table. If you have millions of rows, the 6 scan will scan all this 1 million row, which is the worst case. This is the worst case, and you have to avoid it at any cost. Now the index scan is a little bit better. It's also we will use the index. By the way, in the sequential scan, in the 6 scan, the index is not used. Is not used at all. That's why it will query the entire table. In the index scan, we will use the index, but we will not use its full extent. We will not use the index. We will not benefit from the index to the full extent. We will talk about this also in the next. We will see in the next pages, in the next videos. The bitmap heap scan, this is a range. The range means when you put a where clause in a SQL query, then this where clause will be applied and will bring us a range. At the beginning of the query, it will bring us a range from this point to this point. This is a much better scan, can be done on the table. So these are the 3 types. Now if you look at the first node, the start node, the first node, which is 6 scan. 6 scan, this is scan node. This step will go to the table, fetch the data, and then make them ready to be forward to the next step. So as we have said, the scan node will only fetch the data from the table. 1 row or multiple row, depend. But it will fetch the data and make them ready and present them, submit them, forward them to the next step. Now there are also another types of nodes. Non-table row source, which is the values clauses, and the function that returns set of rows. Each one have its own scan. But what's important also is the third type of the nodes, which is the operations node, which consists of the aggregations, functions, the joining, the sorting of any operation done on the tuples. Now this type of nodes, when we fetch the data with this scan node, in this case we have a sec scan. When we fetch the data from the table, we said that we will forward them to the next step. If you look at here, it says hash join. Hash join actually is a join. It's part of the operations node, which means that the data that we have retrieved, we have fetched from this step, is being done some operations on it with this hash join. So this is the sequence. We fetch the data from the table with the scan node, with any type of it, one of 3 types. Then we will do some operations on these data, whether it's an aggregation, joining, sorting, like order by, or whatever operations that we will do on this data. So this is the execution that will be happen on any in any SQL query. First, we fetch the data, we process, we verify them, we do some other operations on, and the final step is the result that we will get and we will see from this SQL query. So these are the steps of the execution plan. Next thing, each node will, when you see this icon or this arrow thing type, that means this is a node. This is a new node. This is a step. Something will execute on the data. Something will execute. Whenever you see this arrow type, that means this is a node. So whenever you see this node in here, this arrow type, that means this is a node. This is an execution step. And you can see here in this planner we have 4 arrow things. That means this SQL have undergo 4 steps of execution. The start point, we have done some operations on it, then another operation, and then another operation, until we have got the final result from this SQL query. So this is the meaning of the query planner and the execution plan. Now, the execution plan, as we have said before, it is decided by the planner. It is decided, the optimizer of the database will select for you the best possible execution plan. This is the entire talk about the indexes planner and the execution plan. Thank you very much.